Hello and welcome to our course on drone surveying. In today's lecture, we are focusing on drone applications in disaster management. So, what is a disaster? Disaster is a serious disruption of the functioning of a community or a society due to a hazardous event interacting with conditions of exposure, vulnerability, and capacity, leading to risk of human, material, economic, and environmental losses and impacts. And risk due to disaster is defined as product of hazard, exposure, and vulnerability divided by capacity, in which hazard is inherent danger of the disaster. For example, intensity of the earthquake is a hazard. And exposure is how many or how long humans or property are subjected to hazard. So it can be number of humans which are subjected to hazard or for how long the humans get exposed to the hazard. And vulnerability is susceptibility of an affected system to the impacts of a hazard. For example, building quality or aging infrastructure. So aging infrastructure will make a building more vulnerable to hazard. And capacity is ability of a system to withstand and recover from the effects of disaster. For example, having adequate emergency plan or resistant infrastructure. So in case of a disaster, if there's emergency plan, if there's good evacuation plan, still the impact of the disaster can be reduced. Therefore, disaster risk is hazard, exposure and vulnerability divided by capacity. And in order to reduce the disaster risk, we have to reduce hazard, exposure and vulnerability and increase the capacity. Then we have disaster management, which is the organization, planning and application of measures preparing for, responding to and recovering from disaster. So disaster management is taking place at three scales: preparing for disaster before the disaster starts, responding to the disaster, so immediately after the disaster, and recovering from the disaster. So once disaster has happened, then how do we recover from that disaster? And disaster risk reduction is aimed at preventing new disaster risk and reducing underlying causes of existing disaster risk, for example, hazard, exposure, and vulnerability. And this happens through planning and policy and regulations. And disaster risk management is implementation of disaster risk reduction. So, whatever policy or planning or whatever regulations are designed in disaster risk reduction, then they are implemented or enacted through disaster risk management strategies. And these disaster risk management strategies prevent new disaster risk and reduce existing disaster risk. Managing cycle of risk. So, what is cycle of risk? So, in any disaster, we can have disaster risk management at several stages. We can either work towards mitigating the disaster, we can work towards preparing for the disaster, we can work towards having adequate response for the disaster, and then we can work toward recovering from the disaster. So, this is known as a cycle of risk, or this is also known as disaster management cycle. So, it is cyclic process like this as given here. So, in the cycle of risk, mitigation refers to the lessening or minimizing of the adverse effects of a hazardous event. Mitigation measures include engineering techniques and hazard resistant construction, as well as improved environmental and social policies and public awareness. For example, it can be identification of unstable slopes. So, for example, if we identify unstable slopes and prevent people from building houses on those unstable mountain slopes, then this is one example of mitigation. And preparedness refers to the knowledge and capacities developed by government, response and recovery organization, community and individuals to effectively anticipate, respond to and recover from the impacts of likely, imminent or current disaster. For example, if we have early warning system, then that can help prepare us from some disaster. It will provide us a lead time warning of a disaster, maybe 1 week, 1 day or few hours before the disaster happens, which can help us in preparing for the disaster. Response happens during the disaster or immediately after that. It refers to the actions taken in order to save lives, reduce health impact and ensure public safety while meeting the basic subsistence need of the people affected. So, example of response can be search and rescue missions which take place immediately after the disaster. And finally, we have recovery, which happens much after the disaster. It is the restoring or improving of livelihood and health as well as economic, physical, social, cultural, and environmental assets, systems, and activities of a disaster affected community. It is aimed at building back better to avoid and reduce future disaster risk. Talking about India, there are various natural and anthropogenic hazards that contribute to disasters. India is vulnerable to many disasters, and disasters in India are classified as either natural hazards or man made hazards. So, natural hazards are cyclones, tsunami, heat wave, landslides, floods, and earthquakes. And man made hazards are chemical, nuclear, and biological hazards. And disasters originate from either these natural hazards or from these man made hazards. And around 59% of the Indian land is prone to earthquakes of moderate to very high intensity. About 12% of the land is prone to floods and river erosion. Close to 75% of the Indian coastline is prone to cyclones and tsunamis. And 68% of its cultivable area is vulnerable to droughts. In addition to this, hilly areas are always at risk from landslide and avalanches. So there is need for disaster risk management in India. So this map shows various natural hazards which are present in India and their spatial distribution. So there is earthquakes, seismic zones which are present along the Himalayas as well as along the western India. There are also cyclone prone areas which are mostly in the eastern side of Indian coast. There are flood prone areas which are along the large rivers as well as in the Indo-Gangetic plain, as well as on the western coast, as well as in southern part of India. There are also drought prone areas which are present in the Deccan Plateau as well as in the Indo-Gangetic plain. And lot of Indian coastline is also susceptible to sea level rise, as you can see here on the western coast. In the right side shows vulnerability to natural hazard. So most of the vulnerability is very much tied up with the density of population. The right side shows the vulnerability to natural hazard, and it can be seen that vulnerability is very high in the mountainous areas. So to deal with the disasters, there are various agencies involved in managing disaster risk in India at various levels. At national level, there is National Disaster Management Authority (NDMA), National Disaster Response Force (NDRF), and National Institute of Disaster Management (NIDM). At state level, there is State Disaster Management Authority (SDMA) and State Disaster Response Force (SDRF). And at district level, there is District Disaster Management Authority (DDMA), District Emergency Operations Center (DEOC). And these agencies are helped by Indian Space Research Organization, Indian Meteorological Department, Ministry of Environment, Forest and Climate Change, Central Water Commission, and Geological Survey of India. So depending on the disaster, various agencies come to rescue and various agencies come in preparing and mapping the scale and the impact of the disaster. For example, if it is flood related disaster, then Central Water Commission will provide the data for estimating the flood. If it is landslide related disaster, then ISRO or Geological Survey of India will provide information of the scale of the landslide, and Geological Survey of India will provide the type of the soil or the lithography of that soil which is present over there. Or in case there is cyclone which is about to happen, then Indian Meteorological Department will provide forecast related to the cyclone. These agencies therefore regularly use geospatial data at all stages of disaster management, at mitigation, preparedness, response and recovery. Of the various geospatial tools that these agencies used, drones have emerged as one of the most transformative tools in modern disaster management because they offer rapid, high resolution situational awareness that complements or exceeds traditional methods. Drones bridge a very critical information gap that often exists in the immediate aftermath of a disaster. Therefore, they enable safe, efficient, and data rich assessments when ground access is limited or hazardous. So, drones are used for all aspects of disaster risk management for mitigation, preparedness, response, and recovery. In mitigation, drones are used for risk, hazard, and vulnerability maps. They are used for preparing land use regulation maps, suitability maps, and also identifying locations for resilient infrastructures. Drones are also being used for providing base layers for early warning systems, planning for evacuation, and resource inventory mapping and scenario modeling. And when a disaster happens, then drones are used for rapid damage assessment, assessing accessibility or blockage of the roads, and supporting field operations and search and rescue operations. And in the recovery stage, drones are used for tracking restoration of utilities and assessing the progress of reconstruction through change detection and post disaster land use land cover changes. Drones especially matter in providing response to disasters because they provide rapid deployment in minutes compared to hours for traditional methods. Drones also have an element of safety built into it because they can access dangerous or inaccessible areas without human risk. And drone can provide almost near real time data, so which provides immediate situational awareness without waiting for the satellite overpass. For example, if it's a cloudy area, then even the satellite cannot always give clear picture of what is happening on the ground. Further, drones are very cost effective because they can do the mapping and imaging at a fraction of helicopter and satellite costs. And drones provide high resolution, very accurate data to map the scale of disaster and the impacts of the disaster. So let's look into drone applications for disaster management for earthquakes, landslides, and floods. So drones are being used for earthquake response all over the world, especially in rapid damage assessment. So this image shows 3D reconstruction of toppled buildings in 2011 Tohoku earthquake in the top and 2015 Gorkha earthquake in the bottom. And in both the cases, drones were flown around the building and images were collected around the building from various angles. And then, based on these buildings, structure from motion and multi-view stereo was performed, using which dense point cloud was generated. Then, from the dense point cloud, textures were applied, and based on which 3D reconstruction of the building was done. So, in the first case, we can see that a building has toppled over here. And in the second case, we can see several soft story buildings have also toppled in the case of Nepal earthquake. So, by using drone for such kind of mapping, it supports classification of damage severity of the buildings. So, based on the 3D reconstruction of the building, we can classify the damage that those buildings may have undergone, whether it's partial damage, whether it's pancake damage, whether it's leaning, or whether it's a soft story failure. And therefore, drone based reconstruction helps enable quantitative estimation of collapse volume, deformation pattern, and structural failure modes. This is showing another example of drone use in earthquake response from earthquake in Iran. So it is showing drone derived orthomosaic and digital surface model for 2017 Iran earthquake, and then using deep learning based techniques on the orthophoto and digital surface model. The authors have classified the damage level, whether a building is collapsed. For example, these buildings, red buildings are collapsed, whether the buildings suffered major damage, whether they have suffered minor damage, or whether there is no visible or very slight damage. Then such information is very useful to identify which buildings are still safe to inhabit or not, or whether some rapid rescue operation must be taken for the people who are living in those buildings. This damage level information is also very useful in insurance claims which are made after the disaster. Then in recent years, digital twin frameworks have also been developed that not only perform damage level assessment but also perform safety evaluation of the damaged buildings. In the digital twin framework, the 3D reconstructed model from the drone is compared with the reference CAD or the reference BIM model. It identifies the damaged structural components in the 3D reconstructed model based on the reference model. And based on this, it enables damage to be considered in the context of each component's known design and expected earthquake performance. The structural analysis based on the component wise damage is then used to predict a building's post earthquake safety using drone survey. Now, moving to use of drones in landslides, they are very useful in mapping and detection of landslides. A very important activity when landslide happens is to estimate the dimension of the landslide. and these dimension or characterizing the landslide is very important for preparing the landslide inventory map for disaster risk management and disaster risk reduction. So in the left image, the authors have reconstructed a landslide. So this image shows the actual image of landslide, and top left shows the reconstructed image of the landslide. And they compared the reconstructed 3D landslide based on drone imagery with the measurements done using total station, and they found a centimeter level match between the drone based landslide reconstruction and the total station based landslide measurement. So that proved that drone based landslide reconstruction can be used for accurate estimation of landslide dimension. In the second images, the authors have shown that landslide scarp can also be detected from the drone orthomosaic images. So landslide scarp are steep surfaces of exposed soil and rock, and these scarps are key morphological indicator that whether a slope has failed or whether it is actively moving. So if there are lot of landslide scarps, that means the slope has already failed. And if the landslide is not showing any scarps so far, that means the landslide may still be actively moving. So based on these sharp changes in the height and elevation, we can identify the landslide scarp. So these are all the landslide scarp which are also identified in the image on the right. Then drones can also be used in detecting landslides on a very large scale. Advantage of drone here is that they can access steep, hazardous or inaccessible slopes. So these slopes cannot be accessed by humans, and especially under situation of landslides, it is not advisable for humans to also go in these slopes. Then drones can collect digital surface model, digital terrain model, ortho image, and from the DSM and DTM, slope, aspect and curvature can be derived. Then these features help identify unstable zones. For example, if it's a very high slope zone, then it's likely to be unstable and can cause future landslides. And then analysis of the ortho imagery through image segmentation, feature extraction and classification can help in detecting the landslide. So these detected landslides can be integrated with rainfall, geology or hazard models for early warning. So left side shows ortho image. It shows the digital terrain model, it shows slope, curvature and entropy and other slope features. And the right side shows the landslide which is detected based on the slope features as well as based on the ortho imagery features. Then drones are also used for flood preparedness, response and recovery. Drones provide rapid flood extent mapping during peak inundation. So on the left side, there is result from the authors which shows flood inundation, and this has been captured by drone imagery and can be compared with the before image. Then by comparing the flood inundation with digital surface model, the depth of the flood can also be estimated. So for this, digital surface model needs to be prepared. An example of this is shown here. Then based on the flood inundation during flood, we can identify what is the depth of a flood by using this river cross section and by using the digital surface model. This helps in identification of safe corridors, dry patches and accessible routes, as well as it helps in optimizing relief distribution. Drones also help in infrastructure damage assessment, identifying damaged road and crop damage for insurance claim during floods. For disaster preparedness, drone-derived datasets provide high-resolution, event-specific digital surface model that significantly enhance flood simulation accuracy in hydrodynamic models such as HEC-RAS. So in those models, digital surface model is a very important input which is required for simulating the flood. Then drone LiDAR or photogrammetry can generate centimeter level DSM and DTM that can correct errors in currently available coarser digital elevation models. And these DTMs can improve channel geometry, floodplain microtopography, road embankment elevation, and drainage pathways, which directly influence the model's flow routing and inundation extent. So if we have accurate model of DSM and DTM, then we can get more accurate representation of flood simulation, which is very important in disaster preparedness. Further, drone orthomosaics, which are captured during peak water levels, provide precise water boundaries. And these observed extents can then be used to calibrate roughness coefficients, adjust inflow hydrographs, and validate model accuracy by comparing simulated versus observed inundation polygons. There are also challenges in utilizing drone for disaster response. For example, there are regulatory constraints. There may be restricted zones which are in disaster area in which drones cannot be flown. For example, if disasters happen in mountainous area or near the Indian border, then drones cannot be flown over there. They can also be altitude restrictions regarding flying of drones, and they can also be geofencing limits in which drones cannot enter. In addition to this, there are also a lot of operational limitations that one has to face when flying drone under disaster situation. Disasters present difficult flying condition with often strong winds, rain, or if it's a forest fire, then smoke will also be there. And due to these, drones require high density of ground control point. Then because it's a disaster area, it may be debris filled, or there may be a lot of unstable slope, because of which there are only limited takeoff and landing locations. So it has to be planned very carefully. Then in disaster situation, often the power infrastructure is also down, because of which charging and replacement of batteries can become challenging. And there is also poor GNSS signal in valleys or under inclement weather, which reduces accuracy of RTK and PPK positioning, because of which there is navigation risk. Also, the drone cannot find its own position very accurately. Not only that, there is also debris, there is unstable structures, so it is also possible that drone can collide with such debris or unstable structures. And then there are also privacy and safety concerns when flying over affected community, and especially in disaster response scenarios, there may be very limited number of drone operators who have disaster response experience and who are also willing to go in the disaster zones. So in summary, the disaster management process has 4 key stages of preparedness, mitigation, response, and recovery. Although drones are useful in all the 4 stages, drones are indispensable in disaster response, which requires rapid situational awareness. Drones are being prominently used in earthquakes, landslide, and flood disasters for infrastructure damage assessment and detection of landslide and inundation zones. And the DSM and DTM derived from drones is very useful for downstream tasks such as simulation of flood or simulation of structural safety. However, deploying drones in disaster situation comes with its own challenges of poor weather, unfavorable conditions for drone survey, and lack of sufficient manpower who can deploy drones in such situations. With extreme events becoming more frequent and complex, drones provide disaster managers with timely and spatially precise information necessary for informed decision making across all phases of risk reduction. So that was all for today's lecture. Thank you very much.